We'll proceed in vector summation and integral calculus. Vector summation and integral calculus, the arena in which we have waged a war. Vector summation and integral calculus. And we are pursuing into the discussion of before that. I believe it is all right the way we calculated the value of exponential. Okay, we have in that, I believe we can continue, then we will talk about it. Okay, what we are talking now is that what is the interest, what is the formula of interest that someone is getting in a fixed deposit terminology. What is fixed deposit terminology? Is there is a bank and it is giving, it is considering a fixed deposit. You can deposit a money and then money will get interest every year, and every year then whatever the interest is plus the principal amount, total it will become principal amount. This is what recurring fixed deposit, it happens to anyone. Annual recurring fixed deposit means if bank has declared that it would give 50%, it would give 5% interest on the money that is deposited. If someone had deposited $100 or 100 rupees in the bank in the fixed deposit, at the end of 1 year, that will become 5%. I mean, whatever someone has deposited, means interest that will be provided to the person at the end of 1 year will be 5%. On 100 rupees, it will be 5%. 5 rupees he will get at the end of 1 year. So if I say the interest rate is C, C is the interest rate, and that interest rate is 5%. And Y is the amount in the fixed deposit account at any time. At any time, what is the amount of Y at any time? Okay, then I would say Y at any time, Y at any time equal to Y at any time. What is the if I consider Y as the amount that is available in the account anytime? Okay, then what is the Y after 1 year? Then it is Y0, that is the 100 rupees someone had deposited in the account, or $100 someone has deposited in the account, plus interest on $100 that will come as $5. $105 is the amount, that is the Y at the end of 1 year. Now, if he is seeing the Y at the end of 2 years, then it will be 5% on top of $105 that is in his account. 105 plus 105 into 5%. If someone adds it, that is the amount that is available in his bank account after 2 years. If someone breaks it after 2 years, how much is the amount in his bank account? 105. That is the money that he has in account after 1 year. 105 plus 105 into 5%. If someone takes out 105, then it becomes 1 plus 5%. Makes sense? 1 plus C. Now 105 someone has taken out, if someone breaks it, then it will become 100 plus 100 into C. That will become, if I take out 100, then it becomes 100 into 1 plus C bracket close, into 1 plus C bracket close. If someone is seeing the amount at the end of 3 years, it will be 100 into 1 plus C into 1 plus C into 1 plus C. Means at the end of T years, the amount that is available in the account is 1 plus Y0 amount, that is the $100, Y0 into 1 plus C to the power T. Okay, someone would say, what is the big deal here? I know it. This is a typical recurring, typical kind of recurring mathematics is there. Typical. Where if someone has deposited Y0 amount and it is growing at an interest of C%, then after n number of year or t number of year, it will be Y0 and in bracket 1 plus C, bracket close to the power n or t. That is the amount. Now question is arising, what will be the condition? Consider that there is a person, external person, and he is depositing S dollar in the account every year. S dollar in the account every year. Unknowing the person who has deposited Y0 amount in the account, Y0 amount in the account at the beginning one, and then he is saying 5% growth rate that will be recurring every year. Then he is not knowing that there is some external person. This is also called external source. One external source has deposited S amount of dollar at the end of 1 year. Then at the end of next year, he has deposited S number of amount. At the end of third year, he has deposited S amount again. And this is what he keep on doing every year by year. Okay. Now question is arising, how much money a person has in the account after T number of years? How much money a person has in his account at the end of T number of years. What is the money a person has in his account at the end of 1 year? That is Y0, the amount he has paid at the beginning, multiplied by 1 plus C. I can say 1 plus C equal to A. 1 plus C equal to A. A, some term. A. A is a constant here because C is constant. Per annum, the interest rate is C, 5%. Then A, that is 1 plus 5%, that will come as 1.05. That is also constant. So someone can say that the amount someone can expect at the end of 1 year is Y0, that is the beginning amount, into A, that is 1 plus C, plus S amount someone has deposited in the account for which there is no interest because he deposited an account amount just it is before it is happening 1 year, just before, moment before. No interest is provided on top of it. Okay, someone would say, can you tell me what is the amount at the end of 2 years? Then S amount that is deposited at the end of 1 year, it will go with its own interest and it will become S into A. So it will become Y0 into A square plus S into A plus S that he has deposited at the end of second year. What is the money in his account after T years? T years, then it is Y0 into A to the power T plus S into A to the power T minus 1 because the first S will get interest only for T years minus 1 plus S A to the power T minus 2 plus S A to the power T minus 3 plus A to the power 0. Okay, then it will come as Y0 A to the power T plus S and in bracket A to the power T minus 1 plus A to the power T minus 2 plus A to the power T minus 3 plus A to the power 0. What is this A to the power T minus 1 plus A to the power T minus 2 plus A to the power 0? If someone is trying to calculate it, consider this amount is X. We have talked about it. This amount is X. X equal to A to the power T minus 1 plus A to the power T minus 2 plus A to the power 0. Let's multiply X with A. X with A. A into X will be A to the power T plus A to the power T minus 1 plus A to the power 1. If I subtract Ax minus X, it will become X into A minus 1 equal to A to the power T minus 1 A to the power 0. Other will go away. X equal to A to the power T minus 1 by A minus 1. Okay, this is the someone can expect that. So what is the amount that is in the account at any time t, any after any where t is in years, y and as a function of t, y and in bracket and then small t bracket close, y as a function over t, where t is in years equal to y0 into a to the power t plus s into a to the power t minus 1 by a minus 1. That is the amount. Okay, now question is arising that can we use calculus here, calculating a to the power t minus 1 plus a to the power t minus 2 plus a to the power 0. Can we use calculus? So if someone wants to get a to the power t minus 1 plus a to the power t minus 2 or If I reverse it, someone is trying to calculate 1 plus a square plus a to the power 3 plus a to the power t minus 1. Let's divide this. Then how many sections are there? 0 to t minus 1 means t sections are there. Let's divide this full problem into n number of parts. This is what we are talking about, dividing problem into n number of parts. Or here, I will divide problem into t number of parts. Okay, t number of parts, where one part is a to the power 0, one part is a to the power 1, like a to the power t minus 1 into t part. Okay, now we have summation now, summation of t entity, but all entity are not same. To convert summation into multiplication, I need to have all entity behaving same way. Okay, I cannot write 1 into 2 into 3 into 4 as 4 into 5 into 6 and 6 into something, not possible. Yeah, I can write if it is 2 into 2 into 2 into 2 into 2 into 2 6 times, then I can write it as 2 into 6. I'm sorry, I'll rephrase it. If I have 2 plus 2 plus 2 plus 2 plus 2 plus 2 6 times, then I can write as 2 into 6. But if I have 1 plus 2 plus 3 plus 4 plus 5 plus 6, I cannot write it as a multiplication, not possible. Repeated addition can be represented as multiplication, and multiplication can be represented as integral calculus. Main concept is multiplication. Many times I have demonstrated it. This is multiplication, and one line goes through the integral calculus. Integral calculus can solve multiplication, and one line goes towards the repeated addition. Repeated addition can also solve a multiplication. Any multiplication can be represented through integral calculus. Any multiplication can be represented through repeated addition. Okay, in that fashion, if I have a multiplication, if I know multiplication, then I can go for repeated addition. If I reverse it, if I have repeated addition, then I can come to multiplication, and then I can go to integral calculus. It is all right, I believe so. Okay, in that fashion, if I have 4 plus 4 plus 4 plus 4 plus 4 plus 4, I can write as 4 into 6, 6 times. This is called repeated addition. 4 plus 4 plus 4 plus 4 plus 4 plus 4. 4 into 6 or 4 into 7. 4 into 7, 4 into 7, it can be written as 4 into x, where x is 7, or 4 into dx, where limit is x equal to 1 to 7. I'm sorry, 0 to 7. Means, yeah, x equal to 0 to 7. Okay, this is the way repeated addition can come to multiplication, and multiplication can come to integral calculus. Okay, we have taken many examples like this. Anyway, we will try solving it, what we are solving now. Okay, a to the power 0 plus a to the power 1 plus a to the power t minus 1. Let's divide into t different parts. And then each part is different. A to the power 0, a to the power 1, a to the power 2, a to the power t minus 1. But I can make it look similar. If I say first is a to the power t minus x, second is a to the power t minus x, third is a to the power t minus x, or if I reverse it, a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power t minus 4, like that it is up to a to the power 0. Then if now I say, consider it is a to the power t minus x, next is a to the power t minus x, next is a to the power t minus x, like that n is also a to the power t minus x. This is going for t times. Now I have broken my problem into n different parts. Each part is a to the power t minus x. Can I write as, now it is a repeated summation, a to the power t minus x, a to the power t minus x, a to the power t minus x, like that. It is a repeated summation. Can I write it as a to the power t minus x into x times, for x times, a to the power t minus x into x, where a to the power t minus x is function over x. into x. Function over x into x is fx dx. X will go from lower limit to higher limit. So a to the power t minus x dx, where x goes from 0, a to the power t minus x, x goes from 1, t minus x, x is 1 first, and then it will go at the end, t minus x, where x is t, a to the power 0 is 1. So x is 1 to t, and then a to the power t minus x dx. It will come as minus a to the power t minus x divided by logarithmic of a. Integration of a to the power x is a to the power x by logarithmic of a. Okay, in that fashion, I have to take out minus, then it will become a to the power t minus a to the power t minus x divided by logarithmic of a. Now settle down 0 to t, sorry, 1 to t, then a to the power t minus t, that is a to the power 0, that is 1. And 1 is 1, a to the power t minus 1. Minus is outside, it will become a to the power t minus 1 minus 1. A to the power t minus 1. Come down and then minus 1. Divided by logarithmic of a, natural log of a. Okay, this is not the solution what we had brought, a to the power t, come down minus 1 divided by a minus 1. This is what solution we brought. Let's try doing similar thing here. A to the power t minus 1 divided by logarithmic of a. Let's multiply a both sides. Let's multiply a both sides, numerator and denominator. The top will be a to the power t. Top will be a into a to the power t minus 1 will be a to the power t minus a divided by logarithmic of a, and a is outside. Now more or less they are, now we will compare again. A to the power t minus a divided by a into logarithmic of a, or it will become logarithmic of a to the power a, equal to a to the power t minus 1 divided by a minus 1. If I see numerator a to the power t minus a and a to the power t minus 1, more or less they are similar only. If a is very big and t is also big, then more or less it will be similar. If I take the denominator, then a into logarithmic of a. Okay, logarithmic of a will be very low number, very low number. Okay, if it is base of e, if it is base of e, logarithmic is base of e. Okay, people know that how to calculate integration of a to the power x, I believe so. What is differentiation of a to the power x? Y equal to a to the power x. Okay, then if I take a this side, logarithmic of base a, y equal to x. Logarithmic of base a x will be logarithmic of x with base e by logarithmic of a with base e. Logarithmic of y with base e equal to logarithmic of a with base e into x. Now dy by dx, if I do, it will become 1 by y, and that side it will become logarithmic of a into 1. Y will go that side and y equal to a to the power x. So integration means in differentiation dy by dx equal to logarithmic of a base e into a to the power x. Integration will be reverse, and it will be a to the power x by logarithmic of a. So it is all right. Now we have now two solutions. One I brought it through integral calculus, y medium, and one I have brought through the algebra. Algebra is perfect solution, that is a to the power t minus a by a minus a to the power t minus 1 by a minus 1. So integral calculus we have a to the power t minus a divided by a into logarithmic of a. So if I see close there a minus a, if a is very large, then a minus 1 is a only. Here a is large, still logarithmic of a will be very small. Okay, it will be some small number multiplied by a. They are near to each other. If I see numerator a to the power t minus a and a to the power t minus 1, they are near to each other. Now I can say these two solution brought by integral calculus is near to the is very near to what we brought in. Okay, let's proceed. Now, question is why we are lagging in perfect solution. Someone would say, where we are lagging in perfect solution. Where we are lagging in perfect solution is we have taken. Okay, if this is x-axis, then we have each point is a to the power t minus x. This point is a to the power t minus x. This point is a to the power t minus x, where x is growing from 1. So this is a to the power t minus 1, a to the power t minus 2. If a is a very big number, then there will be a vast difference between these two. A to the power, if a is 100, then 100 square and 100 to the power 1, there is a vast difference. 100 square will be 10,000 and 100 to the power 1 is 100 only. There is a vast difference between 10,000 and 100. So our approximation as summation is varying that much, because at the end, if I go through the integral calculus, if I am saying a to the power t minus x dx, then I am drawing a graph called a to the power t minus x with growing x. Then the graph will come like this. Slowly, the graph will come like this, where when x is 1, then a to the power t minus 1 is a big number. Then a to the power t minus 2 is a next number. The graph is going like this. There is a sharp change I can see between the height. When x is 1, height is very big. X is 2, height is considerably small. Okay, in this fashion, if I'm trying to calculate the area, because area, if we see area, if we are trying to calculate the area, then area will give the area underneath it. If someone has to concentrate it very well. If I'm trying to achieve the area of this curve underneath, if I say a to the power t minus x dx, we are trying to calculate area underneath it. Okay, where the gap here is 1, x is 1, 2, 3, 4, 5, 6. So gap is 1. So we now, if I say that I am trying to calculate the addition of the vertical, that is a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3. I believe it is all right. I am going nicely. Okay, let's try again. If I have x equal to 1, x equal to 2, x equal to 3, like that, x equal to 2, x equal to t, I have a graph like this that is going exponentially down, where it is maximum at x equal to 1. If I try to calculate area of this by a to the power t minus x dx, then I get area here. Okay, what you are trying actually, yeah, beginning the original try is I have to add this vertical at x equal to 1, this vertical is a to the power t minus x, then x equal to 2, then I have a vertical a to the power t minus 2, a to the power t minus 1, a to the power t minus 2. If I am adding vertical, then I am adding this vertical with this vertical with this vertical, this vertical. How it is similar to we are calculating area underneath it? Yeah, it is similar. A to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3, I can rewrite as a to the power t minus 1 into 1 plus a to the power t minus 2 into 1 plus a to the power t minus 3 into 1. Why you are doing like that? Because if I say a to the power t minus 1, that is this height, into 1, then it is the area. Then this is the area. This is the area. Unknowingly, if I am saying a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 0, I am actually calculating area underneath the curve. But problem here is that area is rectangular area. First area is between a to x, x equal to 1 to x equal to 2. This area is rectangular area. If I go by the normal summation, then this area is rectangular area. If I go by the normal summation, this area is rectangular area if I go by the normal summation. But if I am going through integral calculus, then this area what we are integral calculus if I am taking, then it is also calculating the area under the curve a to the power x t minus x. Same, both are same. But here a to the power t minus 1 this much, and then where x is 1, x is 2, a to the power t minus 2 is here. We are calculating area of this subsection, which is less than if it was a flat line. If it was a flat line, this is the area, that is a to the power t minus 1 into 1. But if I calculate through integral calculus, then we are getting area, that is between a to the power t minus 1 and t minus 2. This is the area we are calculating. That's why we are getting we are getting different result. That result is higher, a to the power t minus 1 by a minus 1. That has higher value than what we are calculating now, a to the power t minus a, or a to the power t minus 1 minus a by logarithmic of a. This will have lower value because area, okay, I believe it is understandable now. Can someone crack it? Can I make this area same as what area we have through repeated addition? A to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 up to a to the power 0 equal to a to the power t minus 1 by a minus 1. That is through the algebra we brought in. Can I come through integral calculus also? Someone will say it's possible, provided you have gap, you have taken 1, 1, right? The gap you have taken 1, 1, 1. For that gap, if you take x equal to 0, x equal to 1, then this is the height. X equal to 2, then this is the height. Because of this big gap, the area becomes different in both shapes. First, it is flat line, and then full area is coming as a to the power t minus 1 into 1. If you take through integral calculus, then first is a to the power t minus 1, next is a to the power t minus 2, and it goes like a curve, and that curve beneath it, that is the area you are calculating. What is the solution? Let's chop this between 0 to t into infinite times. What I am trying to say, if someone is calculating area between a to the power t minus 1 and a to the power t minus 2, where gap is 1, that area is a to the power t minus 1 into 1. If I go through the algebra, if in between, if I chop multiple times and then calculate the area, then it will be vertical multiplied by very small region. So error will be very less. Makes sense? If I have here, let's do like this. Okay, here if I chop, if okay, I started with this one here, more understandable. If x is 1, this is the height. When x is 2, then this is the height. When x is 1, this is the height. When x is 2, this is the height. Through integration, the top line is like this and bottom line is like this. That is the area in between we are calculating through integral calculus. If I talk about the normal summation, then at x equal to 1, this is the height. At x equal to 2, this is the height. Means this is the area we are calculating through normal summation. Like a staircase, and here it is smooth. A staircase volume area is higher. Now someone would say, do one thing between x equal to 1 and x equal to 2. Chop many times. And then if I take x equal to 1, this is the height. And after that, take very little distance from there, and then this is the height. This section will be so small that it will be exactly similar. If I take x1 and x2 as a rectangular region area, if I chop between x1 and x2 n times, and if I add all the area along this line, then much more clarity I'll get. Okay, someone would suggest like this, much more clarity I get. Then someone will say, are you fooling? How much more clarity I will get? At the end, x equal to 1 and x equal to 2. This rectangular area is you are getting. And if you chop n time, then at the end you will get this area 1. What extra you are getting? Nothing you are extra you are getting. You are falsifying people. Okay, then answer is let's calculate, if this is x equal to 1 and x equal to t. If I chop this into infinite time, then and let's go with the calculation of length, calculation of the summation in same way for both of them, then it will be possible. Yeah, it is possible. Then it is possible. If I chop between x to x equal to 1 to x equal to t 1000 times, 1000 times, and then calculate the vertical, calculate the add all the vertical at each 1000 times, and then go by the area, then they will be similar. Because at the end, if I talk about the only calculating the vertical, then if this is x equal to 1, x equal to 2, earlier we calculated through normal addition this area. But if I chop many times, then we will calculate this area, this area, this area, this area. What I'm trying to say is, let's try again. X equal to 1 and x equal to 2. Let's chop it 10 times. Now I have x at a to the power t minus 1. This is the x equal to 1. Plus a to the power t minus 2. This is, that will be here. Plus a to the power t minus 3, that will be here. A to the power t minus, so it is decreasing. Okay. Now if I say a to the power t minus 1 multiplied by this width, multiplied by this width, both will come at the same stage. Both will come at the similar stage. If I chop into, it will be more clear with this example. What are you trying to say? What I'm trying to say that our interest rate is getting recurring. It is becoming recurring every year. Yeah, every year. Means if I have $100 in account, then 100 will become $105 at the end of 1 year, and $105 will be principal amount at the beginning of second year, and then it will become 105 into 1 plus 1.05 at the end of 2 years. Then it will become principal amount like that. Let's chop this. Let's chop between 1 year into n different parts. Let's chop into n different parts. This is what I'm saying. Let's chop it into n different parts. If I chop into n different parts, then what will be new summation? Summation is same a to the power. What is summation now? If I leave the s part, we have y equal to a to the power t into y0. A, A is 1 plus C, that is 5%. C will become C by N if I am dividing 1 year into N part. Means recurring will happen every section. If I divide 1 year into 10 part, then 1 year into 12 part, then every month the addition of principal with the interest will start happening every month. Interest rate will be at 5% only. Means every month he will get interest of 5 by 12, and then whatever interest 5 by 12 plus $100 that is coming after 1 month, that money will become principal amount. Then again it will be calculated for the next month at the interest rate of C by N, because interest at the end it is calculated every year only. For every month it will be C by 12. So now earlier A was A plus C. Now A becomes, earlier A was 1 plus C. Now A is 1 plus C by N, because interest will decrease every month if we are calculating the interest. 1 plus C by N into N. This is for 1 year, because N times it will accrue, N times it will sum. After T years, then 1 plus C by N, on top of it N into T. Makes sense? More or less what we are saying is, we have divided 1 to T years or 0 to T years into T into N, where N is division of into the 1 year. From 1 year to second year, how much division we have made, that is N. Every N, if N is 12, then every month the principal amount will change. Principal amount will be added to the interest amount every month. If N is 12, if N is 2, then every 6 months. If N is 4, then every 3 months, like that. Now the new calculation is, wherever I have A equal to 1 plus C, now A equal to 1 plus C by N. to the power n that will be replaced of the a and t will remain. More or less, we are dividing into n into t parts. And then interest instead of c, it becomes c by n. Makes sense? Now let's settle down both, both of them. If I go through the repeated summation the way algebra we did, then it was a to the power t minus 1 divided by a minus 1. A is earlier 1 plus c. Now it is 1 plus c by n. A minus 1 will become c by n. 1 will go away. C by n. If n is large, n tends to infinity, then c by n will tends to 0 whatsoever. Numerator is a to the power c, a to the power t n. Earlier it was a to the power t. T will be multiplied by n. A to the power t n minus 1 divided by c by n. Let's go with the integral calculus what did. Integral calculus said it is a to the power t minus a. Now it is a to the power t n the way it was minus a. Okay, or actual was a to the power t minus 1. A to the power t minus 1 minus 1. So it will be like that one, a to the power t minus 1 minus 1 divided by, it was logarithmic of a. Logarithmic of a is 1 plus c by n. A is 1 plus c by n. If someone takes it out 1 plus c by n, what is natural log of 1 plus x? What is natural log of 1 plus x? I don't. But what about if x tends to 0 then? Then it will be x only, because natural log of 1 is 0. Natural log of 1 plus x, natural log of 1 plus x is x if x tends to 0. So if I have logarithmic of a, where a is 1 plus c by n and c by n tends to 0, then it will be c by n only. That side also c by n, this side also c by n. Numerator differs by a, that can be settled down. Numerator differs by a, that can be settled down. Here numerator is a to the power tn minus 1. Earlier it was a to the power t minus 1. Now it is a to the power tn minus 1. There is no much difference between a to the power tn minus 1 or a to the power tn, because a to the power tn is infinite. If n is infinite, then n into t is also infinite. A to the power tn minus 1 and then a to the power tn minus 1 and minus 1, both are similar. Means both are same. Okay, means if I can calculate anything through repeated summation also, provided the gap between each sample is very less. If I did like that, earlier we had gap of 1 year. Between each sample, gap was 1 year. Now every year is divided into n part, and then gap is very small. If gap is very small, if I take for one area, one gap, then if I go through algebra, then a to the power t minus 1, okay, height. If I go next a to the power t minus 2, it is as good as a to the power t minus 1 multiplied by the width. Okay, but if I go through integral again, but the gap is so small that both will be similar. Means if gap is big, consider this is what I'm trying to calculate. Consider this is the gap, and this is x equal to 0, and this is the height. If I say I have at x equal to 0, this is the height multiplied by the width, this is the rectangular region. But if I say I am calculating the area, then this is the area. If I am calculating area considering height at x equal to 0, then this is the height multiplied by width, this is the rectangular area. If I am trying to calculate the area considering everything, then this is the area. Much big difference is there between this rectangle area and this area. But if this length tends to 0, if this length tends to 0, then this can be considered as a flat line. Means it will look like a local linearity, it will look like a flat line, the way we do approximation in circle also. If I divide this circular region into n different parts, and then if I see a particular part, then this is the arc of one part, but this is the straight line. They are not same, but if n tends to infinity, then this curved line will behave like a straight line because the distance is very small. Similarly, if I am trying to calculate area, and then this width tends to 0, very less tends to 0, then this curved line will behave like a flat line. Means there won't be much difference here. Okay, if people are trying to understand in another fashion, then from here, if I take like this, where I'm adding all the vertical at distance of 1 gap, then this I'm actually adding the rectangular region. But if this 1 gap is turned into very small gap, then smaller vertical we will start adding it. That will be similar to the curve line. What is someone can write on the paper, and he would understand more. I'm really sweating. So this is the concept that we can actually follow to have the repeated addition. We'll talk more on it because this is something very key into calculus. Dividing problem into n different parts and solve part by part. Can anyone imagine that a to the power t minus 1, a to the power t minus 2, a to the power t minus 3, this addition up to a to the power 0 can be brought in through integral calculus? No one would imagine it. But we did it making all same a to the power t minus x. Now it will come as a repeated addition and a to the power t minus x dx. And then we proceeded and then we saw that if a to the power t minus x, a to the power t minus 2, t minus 1, t minus 2, where gap is 1, if I reduce the gap and make it very fine gap, then indeed it can be solved through integral calculus very perfectly. Anyway, please do not mind supporting us. I mean, generally you won't find this in the book. This is something that is very special. Okay, people can go more into it. Like if I am saying I am adding 4, 4, 4, 4, 4 times, where 4 starts at 1. 1, if I have x-axis, then 4 starts at x equal to 1, x equal to 2, x equal to 3, x equal to 4. 4 plus 4 plus 4, 4 times. But when I do integration, I write the integration start from 0 to x, not 1 to x. If I had done there also 0, then it would have been exactly same. Anyway, someone can think about it. We will talk more on this. I am not running away. We will do more on it. Please do not mind supporting us. Plus 91 is the India country code 9483160610 a telephone number. Plus 91 is the India country code 9483160610 is the telephone number.